Alright, so we are going to get into Chapter 10. Into Chapter 10, we're going to start talking about exponential functions. And so normally when we start a new section, we start talking about graphs, and things that go along with exponential form is going to also be this thing called logs, logarithmic. And we're going to get into those also into this chapter. But into 10.1, we're just talking about exponential functions, just kind of looking at them and seeing what happens in this idea of called half-life, which is a very, very useful tool. A lot of people use this, and you'll see that's a lot of word problems for what they use it because it's real-world situations. So here we go. We are going to be using the old sequences, geometric and the arithmetic, so you need to know the difference. We talk about concepts near that. So here we go. Alright, so you should read this problem and realize that these two girls are going to get $10 a week for doing their chores. But Allison tries something else. She says, you know what, I just take a penny. But each week you got to double that amount. So I get a penny the first week, I get 2 pennies, 4, 8, and so on. It continues on. And if you look, after 8 weeks, you're going, wow, she is getting ripped off. But there's this actually an old saying. It's just an old tale about a little girl who saves the king's life, and the king says, you can have anything that you want. I'll give you, right now, up to half of my kingdom. And the little girl says, you know what, I'll just take, and she says this same kind of thing, I'll take a penny each day for a month. And by the end of the month, you will see that the girl will obtain more riches than the king had. And we'll see that through this problem. It's unbelievable. With exponential, once it starts taking off, man, it starts going. And it just doesn't stop. Because each time you're seeing that it's doubling itself. It's timesing by itself. So it looks after 8 weeks like she's getting ripped off. You'll see in the end she's going to kill it. So if you look at this, the big thing is we need to be able to write the equation, and that's going to come from old stuff, this geometric sequence. Because each time you're taking 2 to a power. This is times 2, times 2, times 2, times 2, times 2, times 2. So it's 2 is going to be our R that we're looking for. G1 is the first number in our sequence. And remember, it was to the n-1 power because the 8-1 only gets this. It's 7 2's that it's multiplied because the first one is just the initial. It doesn't get any 7. So you got 1, 2, 3, 4, 5, 6, 7 times that you've multiplied 2 to get to this number down here. So that's our exponential. And if you look, it says what is the value if you put in for 0. So if you put 0 in, remember anything to the, so when you take 2 to the negative first power, so when you take 2 to the negative first power, remember what happens when you have a negative power, it sends it down, so it becomes 1 over 2 to the first power, which is really 1/2. So then you take a half, which is 0.5, and multiply it by this number, and that's where they got this number from. Which doesn't make sense because that means before she's even worked, technically she's made some money. We understand that money is so minute, it's not even a penny, but it doesn't amount to anything. But that's what they're just showing you. So if we continue the pattern on, you can see after the 11th week she starts to catch up. But if we added all these, so she would have, this girl total would have already made, $110, and she would have made way less so far in her career. But very soon, in a couple of weeks, she's going to make more money than that girl will ever see, probably in her lifetime. So you can write this. Notice they're taking the geometric form, and they're going to turn it into function notation. The way they're going to turn it into function notation is they're going to combine all the like terms that they can. So they say, hey, if you have 2 to the n minus 1, remember how you combine these guys is if they have the same base. So it could be, this would be the same thing as 2 times n, and since it's normally we're adding the exponents, so this would have to be a negative 1, because that means that n plus negative 1 is really the same thing as n minus 1. And then they separate this, and they, remember we just did this over on the last slide where this becomes 1 over 2 because this negative sends it down to the bottom. That's where all this 1/2 came from, and they simplified, and that's the actual equation. And then what they ask you to do is start filling this in. So you go ahead, I'll do the 15th week with you and show you what that looks like, and then I want you to go ahead and try and do B and C real quick. Should take you a minute. You should have a calculator out for sure. So all you're going to do is for the 15th week, you take 2 to the 15th power on your calculator, then you times it by this, and you realize the 15th week, she's going to make $163. Still not, you're going, that's still not that high. Okay, so let's go to the 20th week. And if you go to the 20th week now, she's all of a sudden, for that 1 week, she's going to make $5,242.88. And if we keep going, go to the 24th, she just made $83,000. And we're only in the 24th week. So if you think about how far it jumps from the 20th to the 24th, it's just going to keep getting infinitely bigger. And so by like the saying that I was talking about with that king, by the 30th day, it's unbelievable the number that this jumps to. All right, so this is going to look, so they're asking you to predict the shape. It's going to look something like this because what it does is it just starts jumping up. These are exponential. They can either jump up, they can go down. Half-life is going to have this type of idea. So all right. So this just shows you, Beth is amazed at how quickly Allison was able to make a lot of money. So she wants to do the same thing. So you could start with $1 and ask for 50% more each week. And so you can look through and see Quentin's plan, and you see that his is much better, and you see that that shape is starting to happen over here. So notice if we write Quentin's plan, it would be 1 because the initial is $1, and then times by 1.5 because you're going to take and multiply it by itself 1.5, and that you're going to do that 1.5. So each time, if you look back, you're taking this and going times 1.5 times 1.5 times 1.5 times 1.55, because you're taking itself and multiplying it by itself and half more, which is 1.5. And so then this is the other plan, which would just be 1 plus 1 times the x. Notice where the x is. This x is in the power. This x is just a multiplier. It's going to be a huge difference. If you choose question 1 to determine how much Beth will earn in 10 weeks, you should just do the same thing where you take this right here, this equation we found, plug in 10, you're going to realize she's going to make $57. If you, if Beth and Allison both use the exponential model to earn the same, so this is going from the first problem back to this one. Who will earn a higher income at the 12th week? Beth will earn a higher one. Use a graphing calculator term will be equal, and so what you do is on the graphing calculator, they put this equation. They put this equation into the graphing calculator. They put this equation because you can actually put more than one, and where it's graphs, it's going to look like this. And what you're looking for is that intersection, and so they show you how to use the little. There's a little X marker that you can move up and down the graph, and you keep moving it up until you found where they intersected, and that would mean that's where they're equal. And then they're saying that this doesn't make sense to the problem situation because Beth and Allison get paid weekly. They don't get paid at 18.4 weeks. That doesn't make sense. They get paid either at the 18th week or the 19th week. They don't get paid in between. So there's never a week that they're going to make the same amount of money, is what this is saying, because it's somewhere the number would have to be like they get paid in the half week or something like that, but that doesn't, they don't get paid like that. They get paid either the 18th week, they get paid the 19th week, which none of those two match up. So for this, because it's not a continuous graph, notice it's not continuous. If I was actually plotting these, it would be like this. It would be the first week's pay, second week's pay, third week's pay, fourth, fifth, sixth, seventh, and so on, and it would not actually be a line because she doesn't get paid 1.5 weeks. So I hope that kind of makes sense of what they're talking about there. You can read through these, it just compares. Alright, so now last thing I think we need to go through is this half-life. So Simon is studying for a big test and trying to stay awake. He drank 12 ounces of energy drink and it contains 80 milligrams of caffeine. And he is wondering how long the caffeine will stay in his system if it has a half-life of 5 hours. That means after 5 hours, half of it will be gone. So you can see this chart that they filled out right here. After 5 hours, he'll have 40. Why? Because that's half of 80. After 10 hours, he'll have 20 because this is another 5 here. It'll go down another half. Another 5, it's going to go down a half. Another 5, it's going to go down a half. All right, what is the initial amount of caffeine? What is the rate of decay? Sorry, 1/2. So they come up with this equation right here. And this one is the only correct one, Emily's, because the half-life occurs every 5 hours. The half-life does not occur per hour. So my exponent up here had to be divided by 5 because in 1 hour, it only has a fifth of the half-life has occurred, kind of, if that makes sense. So they had to divide by 5. Notice here, it's not going to become negative because that would do the inverse thing that we've talked about, and it would flip whatever it touches. No, that's not going to be good. We don't want to flip that. And then this is 5 times t, which would mean that it happens. You'd have to take 60 and divide it by 5. And that would tell you that actually the half-life is in minutes. So that's not good. All right. So these are the reasons kind of why that each one of these is not good. How much caffeine would be in it after 2 hours? Again, you would take the equation we can't have, plug in a 2 right there, and then use your calculator and solve out. You should be able to get this answer using your calculator. Okay, here's what she did. She says that she can take this original equation, which was this, and rewrite it as this, which is 40 times 40t to the 5th. You cannot do this because order of operations says no. You have to do exponents first, then do multiplication. And when she just combines those, she goes out of the order of operations, and that's not going to be good for you. So then they go through, they use a graphing calculator. Use the properties of exponents to rewrite your function so that the variable t is only in the exponents. So what they do here is they rewrite this as, if you have 80 times 1/2, we'll go through this, this is a good problem, you could rewrite this as 1/5 times t. So they broke up the t over 5 into 1/5 times t because top times top, bottom times bottom would make this happen. So they broke this up and they wrote it like that. Well, when you have when you multiply the exponents, that means that you must have had power to a power. So this becomes 80 times 1/2 of 1/5 to the t power. Okay, and then what they do here is they take this and they take 1/2 to the 1/5 and get that answer, which is this weirdo number right there. And then everything else stayed the same. Remember, we cannot multiply this times this because you have to do exponents. We have to do, that's a t right there. You have to do that exponent before you can do that multiplication. No word. All right. All right. Suppose it's taking an antibiotic that extends the half-life to 8 hours. So write the function. So now notice instead of a 5 down here, I know that's hard to see. Maybe zoom in a little bit. Still terrible. Here we go. Notice instead of a 5 down there, it is a 8. All right. So then complete the table. Same kind of stuff that's going through. And you'll have some more practice on this tomorrow. I'm trying to keep the videos a little shorter so you can maybe read through a little bit more, pause them. And if you have questions, make sure you see me tomorrow. We'll be working on these in class. Again, it's all going to be about how much work you put into this. I hope you have a good night, and I will see you tomorrow.